another edition of the Heat Treat Podcast. Today we got Sam Moore from Specialty Heat Treating, Houston, Texas, located in Houston, Texas. And right now we have a very unique situation with oil and gas. And Sam is an expert on this industry because basically, especially heat treat in Houston, they're devoted to heat treat of oil and gas components. So super excited to learn it. We couldn't find better timing to do this. And just would like to say, Sam, thanks for being here and doing this and teaching us about heat treat for oil and gas. But first of all, how you doing? How things are in Texas? And if you could just give a little introduction of special heat treating and a little background of your professional career.
Yeah, perfect. Thanks for having me. Looking forward to it. Nice to meet you, Carlos. So Specialty Heat Treat. Specialty Heat Treat was founded by my father, kind of like you, Carlos, as we discussed.
Second generation brother, okay?
That's right. And he started the company in 1992 when I was a senior in high school. So, I'm kind of a heat treat rat, I guess, because, I grew up working in a heat treat shop, which a lot of people can't say that. We started as a small shop with a couple furnaces and have grown to 42 furnaces and 15 quench tanks presently.
That's a lot of equipment. A lot of
equipment. We fabricate all of our own equipment, actually. And of course, the today's design is much better than the original design. So I went off to college and, worked here every spring break, summer break, Christmas break, etc. Really didn't have plans to come work here. I was going to go to med school, majored in chemistry. But at some point my dad offered me a job and, I was kind of tired of school. And so I came here and learned from him over the years, and eventually, taken the company over and we don't see him as much as we used to.
Same here, a very similar situation. You and I, also second generation, and my father started the company, and I don't see him much here. But I believe that's the best education for a heat treater, just to start on the shop, heating stuff, quenching parts, maintaining the equipment, understanding the equipment, and also solving the issues that we get, like distortion or cold spots, things like that. So pretty similar story to yours. So thanks for sharing that.
Yeah.
And now go ahead.
Well, I was just going to say that's really the greatest advantage, right? Is being able to start in a small shop where there's only 4 or 5 people. And you've got to do everything. You've got to unload the truck, load the truck when it's done, perform the shipping and receiving functions, load the product, run the furnace, do the hardness, as you said, maintain equipment, fabricate equipment. That's, to be able to have the ability to learn all facets of the company is a huge advantage, in my opinion.
It is. So now let's get to the point. Today we're going to talk about heat treating of oil and gas components, right? We have talked with some guests as well, but we have talked about automotive, aerospace, construction, but oil and gas, right? What can you tell us about this industry, this market? We know that it has had its up and downs right now with the situation in Ukraine and Russia. Oil and gas pricings are a trending topic, but can you give us an introduction of this market or this industry? Because there are a lot of heat treaters that they're only devoted, like myself, to automotive, aerospace, the tool industry. But what's unique about the heat treating of oil and gas components and how it differs from other industries?
Yeah, first of all, it's as very cyclical, and I don't know much about the other industries, but the oil and gas market is very cyclical. We've been through several what I would call crashes and several up cycles, and us, along with all the heat treaters in this region, are of course used to that, right? We've been trained on how to deal with that, unfortunately, and some previous down cycles, like in the 08-09 financial crisis, it was a quick cycle down. Like business dropped very quickly for 6, 7, 8 months. It bottomed out for a couple months, and then it picked up very quickly. These last two down cycles, the 2015 down cycle, and then this 2020 down cycle, of course the business hit bottom very quickly, and it's stayed bad for longer, right? So that's been a unique thing about these last two crashes, is that the bad times have been so much longer. So that's been tough, but I can't think of a heat treater in this region that's gone out of business. They were all able to weather the storm. And now we look to be like we're on the way back up. So number one, it's cyclical. I'd say number two, that's unique probably is, we have this, you've heard of the North American rig count that Baker puts out every Friday. That is a great forecaster or indicator for things to come in our business. You can literally look at the last 30 years of the rig count, and you can put our revenues on a chart, and they just mirror each other. So that's a great tool for us. Makes it easy to forecast, right? Let's see, probably, I would say for us, for what we see, we do a lot of larger parts, right? We've only got two of our furnaces are endothermic atmosphere furnaces. Mm-hmm. The other 40 furnaces are all open fired furnaces. So, we don't see a lot of repeat parts per se, because what we're seeing is a lot of raw stock, heavy wall tubing, lots of solid bar, rough forgings, cut up bar, cut up tube, flame cut plate, but it's not to shape. It's not rough, a lot of it's not rough machine. So we really don't know what that part is 80% of the time, or what it's going to be.
And what are the steel types?
So mostly your 4140,
4140, just a regular quenching material.
Yeah. Alloy steels, 4140, 4130, 4130 modified, 4330 V mod, 8630 mod, F22. That's the bulk of what we see. Then we see lots of stainlesses and nickel alloys and super duplexes as well.
And mainly the process is hardening, quenching temper. I assume that you also got some parts that they required carburizing or to prevent decarb. That's why you use endothermic atmosphere.
Right.
But it's mainly those type of parts for the oil and gas industry. And it's this industry has been, as you said, a lot of up and downs, and everybody's talking now about the electric car for the last 2 years. It is a big deal how, oil is going to decrease. And I don't know if you saw it, but Elon Musk actually tweeted yesterday that we have to ramp up on our oil production, especially in the United States, which is crazy, right? So I would assume that you're going to see, a big up on the demand. Do you know something about it, or can you share something about it if you have talked with any of your customers, your contacts, regarding how do you think the industry is going to behave with everything that is happening with Ukraine and Russia?
Yeah, I mean, obviously the world seems to be against oil and gas, right? With all the
Right.
talk about, going green and reducing carbon footprints, et cetera. But a lot of the smart guys we listen to say that, we're in for, demand outperforming supply for the next 2 to 3 years. And so, that kind of, at least in the short term, says that, we've got to drill, we've got to produce more oil. And, with the sanctions we've put on Russia, et cetera, obviously we've got to produce more oil to keep up with demand. So, the customer base we've talked to, we talked to some of the big oil companies and some of the big service companies, the Schlumbergers, the Halliburtons, et cetera. They think the next 3 years is going to be great, a large upcycle. And, so we don't know, right? We just listen to people that are smarter than us and talk to our customer base, and that's where we get our information.
Right, and they have a lot of insight information regarding the production volumes and the investment they're going to make. Now, another thing that I know we didn't prepare for this, but I don't know if you heard, but all the nickel is going up, and since our base trays, or stainless steels or alloys are inner components for or furnaces, and kind of say like it's a raw material, it's skyrocket. So there's a lot of uncertainty in the heat treat spare part business. Do you know something about it? So they're just too soon to ask. Sorry to put you on the spot, but this is like just new news.
Yeah, no, that part of the world supplies a lot of the world's nickel, and
right.
And nickel was already high, and the commodities traders have been saying for months that nickel was going to skyrocket. And it's we buy, but most of what we purchase, as you said, are baskets and trays, and that's done nothing but gone up the last 2 to 3 years. And we just placed an order the other day for like 80 baskets and trays, and it was, of course, way higher than we've ever had to pay. So that's going to be a unique issue for all heat treaters, I would presume.
It's baskets and trays.
Right.
Gas prices are also going up. Not as much in Europe, but they're going up. And there's some scarcity on labor and a lot of turnover. So what a great time to be a heat treater, huh?
Yeah, great time.
Yeah. Now, how manufacturers in Texas have dealt with these up and downs with the oil industry? That's a challenge. Anything that you can share with the community that can help how heat treaters like you have dealt with these up and downs, uncertainties, to keep talent, to preserve talent in your company, and also to be still competitive with this ups on pricing, because somebody has to pay for it, and you have to go back to the customer and say, this part that 6 months ago used to be this many dollars, now we're going to have a price increase because we have an increase on dollars on gas and commodities like trays and baskets. How have you dealt with this?
Yeah, we had to put in a price increase, last September, and I'm sure most heat treaters have done that. In our region, I know that and then we've also got a separate fuel surcharge, right, where we watch the price of natural gas, and here again, I'm sure all the other heat treaters in the area, kind of do the same thing. You can hedge on your gas. At least we have the ability to do that, and you can lock in prices, and we've won in some cases when we've done that, but we've also lost in other cases. That's kind of how we've handled the pricing, et cetera. As far as how have we weathered the ups and downs, as I said, number one, we're used to it. Number two, we've got the rig count that is a great indicator. and tool for us. I was kind of surprised that in this last downturn that we didn't have a heat treater in our region go out of business. And I think in large part that was probably due to some of the government aid that was provided in 20 and 21. As far as how do we weather the storm, every heat treater is probably the same in that your two biggest expenses are natural gas and labor, right? So natural gas obviously takes care of itself. If you're not running furnaces, you're not burning gas. So as long as you're not hedged with too large of a quantity of gas, then that takes care of itself. And yeah, it's just when you don't have many other ways to control expenses, the labor is unfortunate when we get to a point where we have to lay off a percentage of our workforce. We try not to do that. We don't want to lay off trained people. It's because you're in the oil field and you get burned every 4 or 5 years, right? People don't like that, and when that happens to them once or twice, they have a tendency to move on to a different industry. So, there's been a mass exodus here in the last couple of years in the oil field. You hear all the big oil companies talk about how they're having trouble getting talent and having trouble keeping talented employees. So that's a unique problem, and it's tough to deal with.
It is, and now, where do you see heat treaters in Texas going? When the impression of Texas was a lot of course, big, but it's always about oil and gas. The electric car is coming. They're building the plant for the truck in Austin. Do you see Texas becoming more, automotive? Do you see Texas becoming or turning around, look through other industries? And I'm talking about heat treat wise, right? What are you guys doing in order to diversify components? I know there's some other plants in there that is not mainly oil and gas, but also construction. But how are you going to evolve? Because heat treated specifications for oil and gas, it's quite different from CQI and IDOM from NADCAP, which everybody will have to adapt. What can you tell us about how you run things regarding your oil and gas specification? And if you see RFQs from different parts that you're not used to it, how you're going to migrate to those industries?
Yeah, that's going to be a tough ask for the heat treaters in this region, I believe, because there just aren't that many that have those that are NADCAP approved, et cetera, and just aren't. It would be a total change of mindset for our company, as I'm sure it would be for several other companies, just because it's something we haven't done, something we're not used to. Mm-hmm. I think, a lot of people down here are skeptical, right? Can this really happen? Can we really get rid of oil and gas?
I believe that's the consumption that we got from Texas. You've been doing this so successfully for the last, I want to say 100, 200 years. And now, is it going to go away really?
Yeah, I don't personally, I don't think it's going to go away, but I feel like, you're being negligent if you're not considering other areas, right?
Yes.
So, I think people here want to see what this next upcycle is going to be like, right? at least that's what I want to see personally. Is we're hearing that the next 2 to 3 years are going to be really good. I want to see it. Like, how good is it going to be, right?
Right, and you cannot ignore that. If you're getting information that oil and gas is going to go up and they're going to be an amazing 3 years, right. You got to focus on that, right?
Right. So I personally want to see, how good is it going to get? And then I think we'll make major decisions about long-term future for us after that. And I'm guessing most people are kind of in the same boat, you know. As I said, I don't think it's going anywhere, at least in my lifetime. But I think we've got to prepare for it potentially to you know, disappear and decrease. You know, we've tried to diversify over the years, right? I mean, we're 95% oil and gas, and we get the occasional oddball job that might be for some other sector, but it's just, you know, when you get busy and the demand from the oil and gas customers is so high that it's hard to take on something new when you know you aren't going to be able to service your current customer base in the next upswing, right? So I don't, you know, I would say have me on here again in 3 years.
We'll do, but we'll do basically.
And I'll tell you that.
So now let's go a little bit more technical on heat treating, because people like to hear this. So when we're dealing with this type of steel that you just mentioned, you know, very quenchable steels, what's important, you know, to look for, or what are some of the major, you know, possible failures or mistakes? You know, strengths, you know, distortions, you know, quenching agitations. What do we have to look for when we're quenching this part, specifically on non-atmospheric furnaces that are going to be in the main on the hot zone? They're going to go out of the furnace and be quenched. You know, what are the things that they seem to be very basic, but people seem to forget?
Right. Yeah. I mean, I would say, you know, first of all, the oil fields come a long way in developing their specifications, right? You know, for instance, back in the 70s and 80s, you know, my dad tells me that, you know, they didn't hardly test anything. I mean, it was just heat treated, check hardness, and if it was close to what they wanted, they shipped it, you know? I mean, because there was just so much steel being purchased and heat treated at that time. And the oil field has evolved. The quality in the oil field has evolved through failures, basically. You know, every time there's a failure downhole, or every time there's a rig failure in the Gulf of Mexico, you know, the industry analyzes it, looks for root cause, and looks to make changes in the quality system. And so there's been a huge increase in the amount of testing since the 80s and 90s. You know, when I started, it was probably, let's call it 20% of the jobs we processed, we did mechanical testing on. Now we're testing probably 80% of the jobs we process. Very little is heat treated to hardness only, right? And so I'm guessing the oil field's kind of late to that game, right? You know, that we also have specifications that allow heat treatment of large components, you know, 20, 30-inch OD solid components. And, you know, we're testing either a small 4x4 block or now they've upgraded that to an 8x8 block in certain conditions. You know, but that's probably the only industry in the world that you heat treat a giant part and test a small part, and that's okay, right? I mean, so.
And what's your opinion on that? Let's talk a little deeper about large components, right? Because you get a large component, how do you test hardness in this spot and then all the way to this place? Do you have differences, and what's the tolerance? How do you deal with a very large component?
Yeah, I mean, most, even if the customer doesn't tell us, right, we're going to, if it's a 20-foot tube or bar, we're going to test it on both. We're going to test hardness on both ends and the middle, right? And in some cases we may go, you know, 0 degrees and 180 as well. But, as I said, the oil fields has gotten smarter, and most of their critical components or bigger parts, there are multiple hardness locations required, et cetera. And, with the increase and improvements in burner technologies over the last 30 years, our furnaces are much better too, right? I mean, we're surveying furnaces plus or minus 4 degrees in the tempering ranges. So, the equipment's better, the furnaces are better. We learn through failures, right? We've learned to design better quench systems, better agitation, more severe agitation. But the parts are getting larger in general, and mass, of course, is a heat treater's enemy, right? I mean, the larger it is, the harder it is to do a good job metallurgically on that part. So,
and also when it's a very large part, and I've seen a couple of videos of your company, the handling of the part also plays a big role, because when you're talking about a very heavy, large, massive part, how you load it into a hot furnace and then you unload it cannot be done manually. I mean, you have to have a mechanical automated system because it radiates so much heat, right? And also, I like to tell my fellow heat treaters that half of the process is only in the furnace, but the part really transformed is on the quenching, right? So you have to have uniformity on the furnace. I totally agree with that. Heat, but there are way better systems to measure heat uniformity than quenching and flow uniformity. Do you have an opinion on that, or can you share what have been your success stories regarding that?
Yeah, I mean, and as you know, the main principles of heat treatment, right, are load it right, have good equipment that's uniform, and you've got uniform heating, uniform quenching, et cetera, and pick the right times and temperatures, and you should do a good job, right? I think gone are the days of somebody unloading a furnace with a forklift, driving 20 meters or yards across the shop and slamming on the brakes and dumping parts into a quench tank.
I know a couple of shops like that still,
yeah.
but there are very few nowadays.
There are very few. Most companies have recognized the importance of a quick transfer time, being able to keep the parts separated during heating and quenching, and everybody's pretty much have developed what I call sophisticated quenching systems, where you can get in the tank quickly. You've got heavy duty machinery that's moving the load from furnace to tank safely and effectively. So those are the most important things and the critical steps that have to be followed to do a good job metallurgically.
You mentioned you do some water quenching, right?
Yeah. Yeah.
Okay. How do you deal with the scale? The scale that comes from the part. When you have a quench tank and you're, austenizing and quenching a part, and such a big parts, you get to accumulate a bunch of scale in the tank, a bunch of scale in the furnace, and that scale actually, gets stuck on the filters, and you get a lot of dirt in the tanks. That's a major issue that I have with some of my customers or some of the people that I know, that they don't have, atmosphere. How do you deal with that? Because that becomes a very big maintenance issue. And if you don't take care of it, it becomes something negative for the process when a lot of scale is accumulated in your equipment.
For sure. Yeah. I mean, it's a constant battle, right? I mean, so, obviously scale is bad for the cooling systems. The way we handle that is, when the agitators turn on, the cooling systems automatically shut off. And then when the agitators turn off, the cooling systems turn back on, on a delay, right? So we're trying to let the scale settle at the bottom of the tank so that the cooling systems aren't picking up scale constantly and constantly having to change filters, et cetera. The scale is as it builds up and in your tank, you have less quench volume, number one. Number two, the scale retains heat, right? So as the scale builds up, you got less quench volume. You're doing a little bit less effective quenching, and you also can't cool your tank as quickly because that scale is retaining heat. So, it depends on how busy the tanks are, right? How much steel have we processed? We typically drain them and clean them out once to 3 times a year.
If production is not that high, right? I totally understand it. Do you know something about like magnetic filters or something that you can use to scale? Because some of the issues is that people or heat treaters, they don't want to empty their tank in order to clean it because they have so much work that has to be quenched.
Yeah, I mean it is a major pain, right?
It is.
We actually rent big frac tanks. And they come on site. We pump the liquid into them, and then you got 4 people down there, literally shoveling scale. Into tank.
I don't think people know how much scale accumulates. I mean, if you drain the tank, you'll see piles of scale.
That's right. Yeah, piles. You're right. I don't know about the use of magnets as far as that goes. We've never looked into that, and I have no clue, but I'm sure it would make the job easier.
It is. Okay, now let's talk really quickly just to end up our technical conversation regarding agitation. It's well known that when you have water, it's a very severe way of quenching if you compare it with oil or you compare it with salts or polymer or even gas. So what's the secret sauce for agitation on water, right? It's common belief that you have to have much agitation than if you have a quench tank. So what can you share with us regarding water quenching agitation? Pumps, propellers, what works best? How you have to cool it? Just if you could share a little bit of that, we will appreciate a lot.
Yeah, I mean, so we use what I call mechanical agitation, right? So large horsepower motors, driving a shaft that's driving large 26 to 30 inch large propellers.
Okay.
Our small tanks have 1 agitator. Our large tanks have 3, and really our philosophy is agitate it as severely as you possibly can.
Okay, that's my lesson learned. Agitate water as severe as possible.
That's right.
Good.
That's right. And as far as cooling it, we just have evaporative cooling towers, and that's a struggle for us. I mean, as I'm sure it is you. Just because of the hot summers we get here in July and August. I mean, in some cases we've got to, delay some quenches to wait for the tank to get down to the ideal temperature.
Good. What's ideal temperature for quenching on water?
I mean, I think the colder the better.
The colder the better.
To me, the colder the better. Our industry standards dictate that we have to be below 100 degrees to start a quench. We have our tanks set up so that they run until the tanks get to 75 degrees. So our average start temperature is probably 75 to 80 degrees Fahrenheit.
So I just got 2 great things from you as an expert.
Yeah.
The water should be as cold as possible.
Yeah.
And agitated as severe as possible.
That's right.
Those are like the tricks to water quench. Thanks for sharing that with the audience.
Yeah.
Sam, it's been great talking to you about your industry and what you do. And just before closing the show, you've been in the heat treat industry for all your life. You were born and raised on a heat treat shop. You have a very successful career, and by talking to you, you can sense how passionate you are about this industry. There are many challenges, up and downs that you have lived, but what would be something that you would like to share with a young guy that wants to start a heat treat shop, or a young metallurgical engineer that wants to apply for a job on a heat treat shop, or on a company that has a heat treat department, that you would like to have known before all this crazy badness 20 years ago?
Yeah, yeah. And I would say probably it doesn't just apply to heat treaters. I think it's something I've learned that probably would serve anybody in any walk of life. And I would just say, you know, learning to ask, right? Learning to ask, don't guess. It's learning the heat treat industry is tough. There's a lot of science to it, but there's also a lot of art to it, right? And I would say, if I'd learned at a young age just to pick up the phone and ask, or ask for help, ask what my dad or somebody who had more experience, to help me with a heat treat problem, or even something as small as picking a tip ring temperature for a particular grade of steel. That would be my advice. Don't guess, ask.
Don't guess, ask.
That's
And I just would like to add to that comment, which I believe it's a great one. You have to have the courage to ask, because a lot of people, they want to ask, they have the right question, but they don't have the courage. And just I would like to just add that to your great advice. I totally, 100% agree with you. A lot of people nowadays, especially the new generation, they're afraid to ask.
Right.
So just don't be it. I mean, I believe the people that are successful and learn is because they don't have, they're not afraid to ask the questions and feel dumb, right? So that, thanks for sharing that. I believe that's very valuable, very basic, but will help a lot of people in the business. Sam, it's been great talking to you about heat treating. I hope you have great. The next 3 years are very profitable for you and your company, based on what you just share with us. And as well, next time that we talk, I'm not gonna wait 3 years. Maybe next year and see how things are going.
There you go.
You can share with us how things went and how have you dealt with success, because I know you're gonna be very successful in the next years. You're doing things right, and thanks for sharing this with the heat treat community. Thank you so much, Sam.
Okay, we appreciate it. And
No problem. Yeah, go ahead.
call us next time you're in the area.
Will do. And I just would like to remind the audience that we're uploading podcasts with experts on the subject of heat treating for our community. The Heat Treat Podcast, we're on LinkedIn, YouTube, Spotify, with experts like Sam Morhig, whom just gave us great tips on heat treating, on personal advice. And we'll see you next time with another expert power player on the industry on the Heat Treat Podcast. Thank you so much, Sam.
Thank you.